So this is third part of the video for concept video for section 11A power series. So earlier we saw some examples as to how to decide the values of x for which the series converge. And in this theorem, theorem number 3, for a given power series sigma Cn x minus a to the power n varies from 0 through infinity, there are three possibilities. The series converges only when x equal to a, only at the center of the power series. The series converges for all x. Then there is a positive number r such that the series converges if absolute x minus a is less than r and diverges if absolute x minus a is more than r. The number r in case 3 is called the radius of convergence. Radius of convergence of the power series. The radius of convergence is r equal to 0 in case 1 because it converges only at x equal to 0. So in this example, we have seen there it converges only when x equal to 0, only at the center of the power series. So it is the radius of convergence is r equal to 0, or even in this case, when it converges only at x equal to a, what it means is radius of convergence is 0. The radius of convergence is infinity. In the second case, if it converges for all x, that means the radius of convergence is infinity. The interval of convergence, also in short, we normally refer to this one as IC. The interval of convergence of a power series is the interval that consists of all x for which the series converges. In case 1, what is case 1? When it converges only when x equal to a. In case 1, the interval of convergence consists of a single point a. In case 2 corresponds to it converges for all x. The interval of convergence is negative infinity to positive infinity. It has to be an interval. In case 3, there are 4 possibilities for the interval of convergence. So it will be clear from this picture. So it could be when you say absolute x minus a less than r in possibility 3, then what it means is x lies between a plus r, a minus r, and a plus r. X lies between a minus r and a plus r. So the interval of convergence, so definitely when x lies between a minus r and a plus r, it is convergent. Though we don't know anything definite about this point and this point, what happens. But outside of this interval, this is definitely divergent. When x is more than a plus r, or when x is less than a minus r, it is divergent. But the interval of convergence can include the endpoints or not. So there are 4 possibilities for the interval of convergence, which are a minus r to a plus r open interval, or it could be open a minus r closed a plus r, or closed a minus r open a plus r, or closed A minus R, A plus R. So these are the four possibilities for the third case. In the problems that we have done, we can summarize. So for the geometric series, as we know, that only when the common ratio is less than 1, absolute value of the common ratio is less than 1, then that means that the radius of convergence is equal to 1. So you can write this as absolute x minus 0 less than 1. That means that radius of convergence would be equal to 1. What is the interval of convergence? Which is negative 1 to positive 1. In the example 1 that we have done, we saw that it converges only at x equal to 0. That means the radius of convergence equal to 0. In example 2, um, we saw that r equal to 1 and the interval of convergence is 2 to 4. If we actually considered the endpoints of the interval 2 and 4 separately and plugged in, then we proved that it converged at x equal to 2, but it didn't converge at 4 at the endpoint. But in between 2 and 4, it converges. So these are some of the things that we already saw.